In this lecture, we take the question based on the Euler's theorem. Question is, if u is equal to tan inverse of root over x cube plus y cube whole divided by root x plus root y, then find the value of x square uxx plus 2xy uxy plus y square uyy. We have given that u is equal to tan inverse of root over x cube plus y cube whole divided by root x plus root y. Then we have to find the value of x square uxx, means partial derivative, second order partial derivative of u with respect to x, plus 2xy uxy plus y square uyy are x square del 2u del x square plus 2xy del 2u del x del y plus y square del 2u del y square. Now we define what is the we see what is the deduction of Euler's theorem for homogeneous function, or which method is applied to solve this question. So here we use the deduction of Euler's theorem for homogeneous function. If it states that if z is a homogeneous function of two variables x, y of degree n, and z is equal to f of u, then x del u del x plus y del u del y equal to n f of u upon f dash of u, which is represented by g of u. And second one is the x square del 2u del x square plus 2xy del 2u del x del y plus y square del 2u del y square, which is equal to g of u g dash of u minus 1. Now in this example, we have to only find out the second part of this theorem. So let us try to find out what is the f of u, f dash of u, and n, and then after that we calculate g of u, then we calculate g dash of u, and if we substitute the value of g of u, g dash of u, then we are able to get the value of this given expression. From 1, we have u is equal to tan inverse of root over x square x cube plus y cube upon root x plus root y. Let z is equal to, let us try to transpose this to this side, or we can take 10 of on both the sides. So 10 of u is equal to cube root square root of x cube plus y cube upon root x plus root y. Now here, if we see about the z, let us consider it is z. So z is equal to root of x cube plus y cube upon root x plus root y. Then we are able to define that this function z is homogeneous function of x and y are not. So let us try to do it, and also find out, let us try to find what is the degree of this homogeneous function. So we have to first multiply and divide by root of x cube in the numerator as well as denominator of the expression. So root of x whole cube into root of x cube upon x cube plus y cube upon x cube. In the similar manner, root x multiplying, so root x also dividing over here. So root x upon root x plus root y upon root x. Now x to the power 3 whole to the power 1 by 2. So it is x to the power 3 by 2. Similarly, root of x can be written as x to the power 1 by 2. Now it is x cube upon x cube is 1. Y by x whole cube. Similarly, this root x upon root x is 1. And root of y upon root of x is root of y by x. So clearly, this term, this let me again write down. This is x to the power 3 by 2, and this goes to numerator. It will become minus 1 by 2. So x to the power 3 by 2 minus 1 by 2. And the remaining term is root of 1 plus y by x whole cube whole divided by 1 plus root y by x. So this is nothing but, this is the term which has the power 0. So we can write down it is f of y by x. And again it is 3 by 2 minus 1 by 2 is 2 by 2. X to the power 2 by 2 means x to the power 1 and f of y by x. So now This z, which is written as root of x cube plus y cube upon root of x plus root of y, is homogeneous function of x and y of degree. What is the degree of this? It is only 1. And f of u, which is equal to z, is given by 10 of u. Hence, by reduction of Euler's theorem, x square del 2u del x square plus 2xy del 2u del y del x del y plus y square del 2u del y square, which is equal to g of u z dash of u minus 1. Let us first try to find out what is the value of g of u. So g of u is equal to n times of f of u upon f dash of u. Here the degree of the homogeneous function is 1. F of u equal to 10 of u. So let us put all these values over here. N is 1. F of u is equal to 10u. F dash of u is derivative of 10u with respect to u. So 1 into 1, 1 to something is, this will become 10u upon 10u, and derivative of 10u is nothing but sec square u. Let us write down 10u by sin u upon cos u, and sec square u is 1 upon cos square u. So 1 cos u will cancel. This cos u goes to numerator, so it will multiply with sin u. So this can be written as sin u into cos u. Let us multiply and divide by 2. So it will become 1 upon 2 into 2 sin u cos u. But we know that again, 2 sin u cos u is nothing but sin 2u. So sin 2u upon 2, this is the value of g of u. This value. Now, let us try to find out the value of g dash of u. So g dash of u is nothing but the derivative of sin 2u upon 2. Derivative of sin 2u is 2 cos 2u upon 2. So this 2 and 2 will cancel. We have cos 2u. Now we have to substitute all these values in equation number 2. Putting our values in equation number 2, we have x square del 2u del x square plus 2xy del 2u del x del y plus y square del 2u del y square, which is equal to g of u into g dash of u minus 1. G of u is sin 2u upon 2. G dash of u is equal to cos 2u. So let us put over here sin 2u upon 2 and whole times of cos 2u minus 1. But cos 2x is 1 minus 2 sin square x. So here we can write down. And sin 2u is 2 sin u cos u. Cos 2u is 1 minus 2 sin square u minus 1. So this plus 1 and minus 1 will cancel. This there should be minus sign. And this 2 will also cancel. So minus 2. Okay, this is again we simplified sin u into cos u into minus 2 sin square u. So if we open the bracket, this 2 minus 2 sin u into sin square u is sin cube u, not t square, it is cube into cos u. Therefore, x square del 2u del x square plus 2xy del 2u del x del y plus y square del 2u del y square, which is equal to minus 2 sin cube u cos u. This is the desired result of x square u xx plus 2xy u xy plus y square u y y. Thank you.